Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, today lesson I will teach you on ARIMA processes, and this ARIMA processes is known as a auto-regressive integrated moving average, and these ARIMA processes also known as a Box-Jenkins processes. So ARIMA process takes ARMA process, which include the integrated of differencing, or in ARMA we have two model involving two model. In ARMA we have AR, or autoregressive, and the MA, moving average. But for this ARIMA process, we integrate I here. I is referred to differencing. So the model becomes ARMA, ARIMA, ARIMA. So this model is also known as a Box-Jenkins process or Box-Jenkins model. So ARIMA model takes terms the same as what you call the ARMA process. So if you refer to ARMA process, this is the equation for ARMA process, ARMA PQ. So ARMA PQ takes a two time series model, ARMA model, AR model, and MA model, and this is the this term is the AR model, AR, and this term is a MA model. Okay, so we normally refer to AR model when we want to conduct the ARIMA model. Okay? So this is a AR model. So when you do a differencing for this model, and the model become ARIMA. So if you do a differencing, the model become ARIMA. The differencing here is the differencing. So if you do a differencing, the model here become ARIMA model. So ARIMA model, before that, ARMA model, it takes a autoregression and moving average. And autoregression, we know that's for ARP, so we have phi 0 plus by phi 1, yi minus 1 plus by phi 2, y minus 2 plus by phi p, y minus b plus by epsilon I. And this epsilon I is shared together with MA and AR shared the same EI. Then for the MA model, theta 1 epsilon I minus 1 plus by theta q epsilon I minus by q. So let's say I want to write the MA2 model, for example. MA2 is equal to what? Equal to epsilon I plus by theta 1 epsilon I minus 1 plus by theta 2 epsilon I minus 2. This is how we write MA2. Now let's say I want to write AR2. AR2 is equal to phi naught plus by phi 1 yi minus 1 plus by phi 2 yi minus 2 plus by epsilon I. These are AR2 and this is AR2. So if you combine together, if you combine together, we'll get, let's say I want to write ARMA 2, 2, for example, ARMA P is equal to 2 and Q is equal to 2. So ARMA 2 is equal to yi equal to 5 sub O plus by 5 sub 1 yi minus 1 plus by 5 sub 2 yi minus 2, and then plus by the MA2 theta 1 epsilon I minus 1 plus by theta 2 epsilon I minus 2, and then don't forget to put the error term here, epsilon I shared together, shared between AR and MA. These are how we write the ARMA 2. Now, if I put here, I integrate here, if I want to write ARIMA, so let's say I want to find ARIMA 2, 1, 2. So meaning to say we do a differencing here, one differencing here. So to write here, to write the model here, so we need to do a differencing here. So I will show you how to do a differencing here. So in other words, for ARIMA, we need to do a differencing. Okay, how to do a differencing? So I want to show you how to do a differencing. Okay, so this is how we do the differencing. Okay, let's say we have data here. So let's say we have the price of stock here for Dow Jones stock in October 2015. The graph here shows the uptrend. This is an uptrend graph. This is an uptrend graph. This is uptrend. So when we have this type of data, so we need to adjust, or we need to make data stationary. So in order to make a data stationary, you need to do a differencing. Okay, so when I do a differencing here, so then I plot the graph here. The graph here become like this. And these are the first graph. These are without differencing, or in other words, your D is equal to 0 here. D is equal to 0, no differencing. And here, D is equal to 1. And after we do a differencing, we get the graph like this. Then from here, we can get the data here becomes stationary. So here is stationary. So when we have a stationary data, we can apply AR model, ARMA model. Okay? So the differencing, the purpose of differencing is to make the model stationary. So for this case, we do a differencing. So how to do a differencing? Okay? So the process of differencing is very simple here. So you can the formula for differencing. Okay? So let's say I have here. Let's say I have let's say I have the data of Dow Jones just now. This is a data for Dow Jones. Okay? So here is data for Dow Jones. So this is the data for Dow Jones, and how we do. I want to show you how to do a different things. Now, let's say here I put here is a Y here, YI. So the difference things here is the new data here. Let's say I put here is ZI, the new data for differencing. So the first order differencing is yi minus by y sub I minus 1. So meaning to say, this first differencing here is the new, here is zi here, z1 here, is the difference between this value and the current value with the previous value. So meaning to say, this one is equal to, this zi is equal to 164 16422 16472, okay, 16472.37 minus by the previous one. So minus by 16272.01. So Z1 here is equal to, here is we have 3.37, here is 0.0200 or 200.36. This is the value. Okay. The second value here is referred to this part, this value minus by the previous one. So I have here 16776.43 minus by 16472.37. So if you deduct here, you'll get 300.06. So this is the value. And the third one is this value 16790.19 minus by 16776.43. So the value here is equal to 13.76. So these are how we do a differentiation. Yeah. So meaning to say the current value of yi minus the current value yi minus by the previous value of the previous value of yi. So in other words, zi is equal to y sub I minus by y sub I minus 1. These are the first different things. So once you get the first different things here, then if you plot this graph, so this is the first graph here. This is the first graph. This is the price here. This is the first graph. So then this is the second graph refer to this data. So you can see that the data here become stationary. So in other words, if you draw a graph here, if you find that the graph here is an upward trend or downward trend is an upward trend, you can do a different things to make the data stationary. So when you do the differencing, the model here become ARIMA model. So we have a few levels of differencing. We have up to D, APQ, APQI, PQ, PDQ. So we have up to D level of differencing. Okay. So we have a D level of differencing. Okay. Now you have differencing. You have PDQ, D level of differencing. Okay. Now, let's say I want to do a second order differencing. So, my first order differencing is that Zi. The first order differencing is Zi equal to Z sub I is equal to Y sub I minus by Y sub I minus 1. These are first order differencing. First order. Now, the second order differencing is, so this is D is equal to 1. Now, the second order differencing is you just substitute. So now Zi become, Z sub I become. So you just do a differencing here. So this is the first order. The second order become Y sub I minus by Y sub I minus 1. The first one. Minus by, so here become Y sub I minus 1 minus by Y sub I minus 2. This is known as a second order differencing. Second order differencing of D is equal to 2. Okay. Now here become, if you simplify this thing, you will get so if you simplify this thing, you get, so Zi here become Zi become yi sub I minus by, so if you negative pi minus by negative pi minus 1, so you have negative 2 y sub I minus 2. So negative and negative become positive, sorry, y sub 1. So plus by yi sub 2. This is a the second order differencings. What about the third order differencings? So the third order differencing, you differencing the second order. So the third order differencing become Z sub I become, so the second order this one, so the third order is y sub I minus by y sub I minus 1 minus by 2 y sub I minus 1 minus by y sub I minus 2, okay, then plus by y sub I minus 2 minus by y sub I minus 3. These are third order differencing. These are third order differencing, or d is equal to 3. So you can simplify this equation. Okay. So these are third order differencing, and the process goes on, goes on, and goes on, goes on. You can do a difference up to d order. So this is first order, this is second order, and here is your third order difference. So for our case here, for our case here, we just restrict ourselves into two order differences. We do not go to beyond that. We do not go to more than two. So just we do the first and the second order differences. So now, how to decide how to decide which model to be chosen if we do the what model to be, how to identify the model here. Now, if an AR process, okay, so now the autocorrelation of different series is less than negative 0.5. Okay. So now, um, now ARP, if you run or you calculate the ARP and AQ model, you have a unit root. Now, if your unit root here, this is a unit root. I will explain you what is unit root later. This is a unit root. Now, if your unit root here is now, if your unit root here has a unit root, the level of differences should be increased. Then for MAQ model, if process has a unit root, then the level of differences should be decreased. Eh? So for AR process, if you do a AR process, and then if you have a unit root, then the level of differencing should be increased. Now, for MAQ process, if you have a unit roots, then the level of differencing should be increased. Now, later on, I will explain what is unit roots here. So, now, let's say we go to this part. Okay. So, how to identify the ARIMA model? Okay. So ARIMA model is also referred to ARMA model. The difference here is we have a different things there, ARIMA. So for ARMA model, okay, before we can refer to ARIMA model, we have to refer to ARMA model. So for the ARMA model, now if you have to find your ACF and PACF. ACF is autocorrelation function. Okay, and PACS is partial autocorrelation function. So now for AR model, so if the autocorrelation function is a geometric or is what you call the tail of series or geometric series, then your PAC have a P significant legs, then we select AR model. Now for the MA model, if you draw the ACF and PACF graph, so if you find that the PACF is what you call the tail off or geometric series, then your ACF is a significance at leg Q, then we choose MA model. Now, we choose ARMA model if we have ACF and PACF is a geometric series. So both of them are geometric series. So for example, for this case, okay, for the case number 1 here, let's say I have here is a PACF. Your PACF is like this, like this. Let's say your graph of PACF. Your graph for PACF for this one is like this. PACF is geometric series. I have here like this. This is a geometric series. Okay, it becomes tail of that. This is what I call the geometric series. Whereas for the PACF, we find that the graph is like this. This is like this, then goes down here. This is what I call the AR1. This is AR1. Okay. Now let's say for the MA model, your PACF is like this. ACF is like this. We have spike here, then it goes down here. This. Then while your PACF is a geometric series, is geometric series. Then this is what I call MA1 model. MA1 model. This is MA1. Now, if the graph is like this, so I have here this, and your PS is also the same. Okay, this. Okay. Sometimes goes down there. Sorry. This. Okay. Maybe like this. This. So this is known as a ARMA model. Okay, ARMA model. Okay. Now, so to find the different things and to find what model to be used. So first of all, we need to plot the time series and try to identify whether there is a trend or not. Now, if you have a trend, then if you find that you have a trend, then generally requires different things. Eh? So it requires different things. So we generally restricted ourselves to first and second order different things. Okay? Now then after that we go to the second procedure is to calculate the ACF and PACF as like I just explained just now, if you find that your graph is like this, and so this is known as a geometric series, and here model, MA model, or ARMA model. Okay, so you can detect based on the graph there. Okay. Okay. Now, if you refer to your ACF and PACF, now if PACF and if is PACF and ACF do not converge to 0, then you need to have different things. Eh? One more thing is that if you draw a graph for ACF and PACF. Now, if you find that your ACF and PACF do not converge, so you need to do a difference. Converge to 0. Now, if all the ACF values are near 0, then the time series is probably random and can be modeled as this one. So let's say I draw a PACF here, ACF. Now my ACF here, let's say I draw ACF. So ACF is like this. Let's say for example, near to 0, or the ACF here is ACF graph. So ACF is like this, near to 0 here. This is known as a white noise process, or yi is equal to phi sub O plus by epsilon I. Now, if we do a first differencing, we find that after a first differencing, we then find that the graph is like this. So this refer to a random walk, and the random walk become 5 naught plus by yi minus by y sub I minus by 1 plus by epsilon I. So if you do a first difference, and you find that your ACF is converged, is near zero, so your time series is a random walk, or y sub I is equal to 5 naught plus by y sub I minus 1 plus by. This is a random walk model, okay, and this is a white noise model. So depend on without different things, you find that your ACF value are near to 0, then you refer to white noise. Then after differencing, you find that the same as the first, this one, ACF near 0, then the model is known as a random walk model. It's a special name, white noise and random walk model. Okay. Now I want to show you how to do a differencing here. Let's say I have the data here. So the data here, so you can do the differencing here. So this is the first differencing, this is second differencing, this is a third differencing, this is a fourth differencing. I show you the formula up to the third differencing, so you can also apply this formula to find the fourth differencing. So how to find the first differencing? So the first differencing is just a, let's say this is a Zi, this is a Zi, Z, this is Zi, this is Zi, this is Zi, okay. This thing is Zi, here is Zi, all these things. These are first differencing, second differencing, third differencing, and fourth differencing. So the first differencing, the formula here is Zi is equal to Y current minus by Y previous. So in other words, this value is equal to Y current, this is a current, this is a previous. So this value is equal to 5.808 to 51 minus by 2.690,575 is equal to 2.690,575 is equal to first difference here. And this value is equal to this negative 90148, negative 0.90148 is equal to 4.906769 minus by 5.80821. So you get negative 0.9048. This value is referred to 6.11947 minus by 4.906769. The value there is equal to 1.212706. And this value 2.01 is referred to 8.135326 minus by 6.11947. So we get the value of 2.015852. These are, we get the first differencing. These are first order differencing. So and so on and so forth. You can solve this part. Okay. Now the second order differencings, you can apply the formula just now. The second order differencings, you can apply this formula. This is the formula for second order differencings. I show you this is the formula for second order differencing. This is a formula for second order differencing. This is a formula for second order differencing. You can use this formula for second order differencing. So if we apply this formula, the formula is written as yi minus by 2yi minus 1 plus by yi minus 2. So the second order differencing is yi. So second order differencing is zi is equal to yi minus by 2yi minus 2 plus by yi minus 3. These are second order differencing. So in other words, if you, this is second order differencing, this is a second order differencing. Now, in other words, if you want to find this value, negative 3.59206, you can apply this formula. So, negative 3.5, to get this one, you can apply this formula, zi is equal to yi. So, here is yi, this is yi minus 2, sorry, yi minus 1. This is yi minus 1 minus by yi minus 2. So yi, this is yi. So yi is for this yi minus 2, and this is yi minus 3, and this is yi minus 1, and here is yi minus 2. So zi is yi 4.906769 minus by 2 multiplied by yi minus 1, 5.808251, then plus by yi minus 2 is this one, 3.11767. So you will get the answer of negative 3.59206. These are value for second differencing. And this one, the value here, 2.11418, how to get here? This value is equal to 2.11. This can be right as a equal to yi for this case, yi here is equal to 6.11947, 6.119474 minus by 2 multiplied by yi minus 2, yi minus 1, yi minus 1. For this case, yi minus 1 is this one, 4.2 multiplied by 4.906769, Then yi minus 2, this one, 5 plus by 5.80825. So the answer here become, the thing here become, so the answer here is equal to 2.114188. This is how we get this value. Okay. Now the third one. So how you get the third one? So the third one is this one, 0.803147 is equal to this value minus by 2 this value minus by this value minus by plus by this value. So 0.8. Okay, let's say I want to find this one, this thing, this value. Let's say I want to find this value. This thing become, this value become, this value, how you get that value is equal to your zi is equal to zi is equal to 8.135326 minus by 2 multiplied by gini, 2 multiplied by 6.119475, then plus by 4.906769, and the answer here is equal to negative. So we'll get the answer of negative 0.80631. Okay. Let's say we try to solve this one. So here 6.11945 multiplied by 2, then plus by 4.90769, then plus by 8.13536. Multiplied by 2 plus by 4.906769 plus by 8.13536. So negative 0.86. So these are how we get the value here. So you can try all the value there, okay, to find how to find the differencing there. And the simplest way to do a differencing is, once you get the first order differencing by using the formula zi just now we use a different formula. Okay, now we use the other formula. Once you get the first order differencing, to find the second order differencing, we just so the first order difference is zi is equal to yi minus by yi minus 1, the previous one. So this thing is equal to this particular value equal to this one minus by 1, you get this one. So the second order difference is just, you just pick up the first, for the second order difference, you just pick up the first order differences, you just multiply the minus by this one. So the second order, you don't have to use this formula, the complicated formula, we just pick up from this value. The second order difference is just negative 0. This value is negative 0.90148 minus by 2.690575 is equal to negative 3.9206. These are the second order differences. And the third order differencing, you use the second order differencings. Okay, to find the third order differencing, you use the data from the second order differencing. So this value is from 2.114188 minus become plus 3.52206. You get 5 point, here is equal to 5.706246. So these are how we get the, how you find the differences here. So in other words, to find the second order differencing, you just get the data from the first order differencing. To find the third order differencing, you get data from the second order differencing. And to find the fourth order differencing, you just use the third order differencing. And to find the first order differencing, you use the original data. This is how we find the differencings. Now, so I want to show you how to find the ARIMA model. Okay, so how to get the ARIMA model, and the ARIMA model here is quite complicated here because of involve AR, 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 involve AR, involve AR, involve the ARIMA model here becomes quite complicated because of it involves AR and MA model, and on top of that you have to have a different things here. So to find AR is quite straightforward. You can use a linear regression. This is a linear regression. Okay, regression. And MA is not using a linear regression. This is quite complicated. You need to use the maximum likelihood estimation, maximum likelihood, or because of you cannot use just simply a linear regression. You have to do the iteration. So you have to do iteration to find the MA model. So in order to do the iteration for maximum likelihood, so likelihood, so you need to use the computer software, or you need to use a time series software to solve this problem. So I will advise you to use either use the SPSS, or you can use the Excel. So you can use Excel. But if you want to use Excel, you have to download the software from what I call one's website, the software known as a real statistics for ARIMA model. So from there, you can easily calculate your ARIMA model. Okay, so I want to show you how to get the software here. you can go to this website. Then you can download the model here. Then you can use uh, to find the what I call uh, um, the ARIMA model. Okay? So can you go to? You can refer to this website. You can refer to this website. This is realstat.com. You can type this website realstat.com. If you go to that website, you go to this website, you go to real www.real-statistic.com /time series, and this is /ARMA processes. Please go to this website. Okay, then you can download the software here. It's Excel. You can download this software. The software here is known as a real statistic resources. You can download the software, a free download. So you can download here. Here you have download here, free resources. You can download the free resources here. You download here, free download. Okay, and then if you are using Excel 2007, you can click here to download and just free download here. You have the icon here. You have download already. Okay, real stats. Okay, these are the software here. So I just click here. Now, so there is a pop-up here. You just enable macros. Then you can, now let's say I have the ARMA 211 process here. ARIMA 211 process. This is the data here. So my data here, this is my data. Okay. So this is my data. So this is my data. So I just copy this data. Okay. I just add a new worksheet here. A new worksheet. So I put here. Now, I have the data here. Let's say here is the data for the price of a certain stock. Let's say Y stock. The price for Y stock here. So up to 105 days. So the price for up to 105 days. Now you want to find, you want to plot here. You want to find what model to be used. Okay, what model to be used. So now let's say for this case, I do not know what is the graph look like. So I can draw a graph here. So you can draw by using Excel, or you can draw by using SPSS and so on. So for let's say I want to use SPSS. Okay, so you can use Excel, or let's say for graphing I use SPSS. So let's say I cut this data here. I copy this data into SPSS. This data into SPSS. I copy here. So I just cut this one. Copy here. So just copy here. Control C. And then I go to SPSS. SPSS. Now this is my SPS windows. So I just you have to be familiar with SPS. So just put here data here. So just yeah. So here is my data. Okay. This is SPSS, my data. I just give a name of this variable. Variable view here is my time period, okay, time, and here is my Y data. Okay, this is my data. So I want to show you the graph here. So just plot the graph here. So I go to analyze. So I go to forecasting here. I just click sequence chart. I just draw a sequence chart. So my variable is Y, and the time axis is labels, and the time axis label is time. So I just plot here timelines. Okay, just continue. So just draw a graph here. So we can see that this is something is a trend line here. So copy here, copy there. Okay, just copy here. I just put right here. So now, if you look at this graph, uh, copy this one. Look at this graph. You can find that there is a sort of the upward trend here. There is a sort of upward trend. So, but we do not confirm yet. We cannot confirm yet until we do a run the what you call the model ARIMA model. So we assume that there is a trend here. So there is sort of trend here. The data is not. We can assume the data is stationary here, or we can assume that the data is sort of there is a trend there. Okay. So let's say I assume that there's a trend there. Okay. Now, in other words, for if we find that there's a trend there, we need to do a different things. So that's why that involve ARIMA model. So we need to do a different thing. That's why we say that we need to use ARIMA model. So ARIMA different things. ARIMA model. But we do not know whether AR, MA, or the combination. But from this graph, assume that there is a trend line here. So the upward trend there. So we need to do a different things. So let's say I try first order different things. So D is equal to 1. Let's say for example D is equal. Then before that, maybe we can draw the graph here. So let's say we go back to the SPSS. We go back to SPSS. Just go back to the data there. Okay. Now, let's say I want to find the autocorrelation for this function. I want to find the PACF and ACF. So just go to forecasting here, and then before that you go to analyze. Okay, you go to analyze tab, and then you go to forecasting, and you go to autocorrelation. Okay, autocorrelation. Now I want to find the autocorrelation and partial autocorrelation. So I just pick up Y here, just Y options. So I do a leg 15 text. So just continue here. Just click OK there. So there is a graph there. This is a ACF graph, and this is a PACF graph. Now, by looking at the ACF graph here, so we can expect something here. This is what we call the we can say that this is a like we have two the PACF. So the rule of thumb here. So if you go to the rule of thumb, how to pick up the model here for AR model. So if I go here, the rule of thumb here, how to pick up the model. So AR model is the ACF is a geometry and P significant legs. So geometric and P significant legs. geometric and P significant lag, ACF geometric and P significant. So by looking at this graph, so we can see that your PACF here is what I call the we have the we have two spike here. We have two spike here. So if I refer to AR model, there is a two spike here. So we can this is what I call the geometric series. This is a geometric series is a what I call the trend here is a this what I call the tail off is tail off tail off. It look like tail off of geometric series. Geometric. These are ACF. And then your PACF, your PACF, your PACF, you have two spikes here. You have two spikes, 1 and 2. The rest is near to 0. Eh? So two spikes. There is two significant spike. Two significant spike. Two significant spikes. So we assume that this is AR2 model. Now, what about MA model? MA model, so if you look at the row of thumb here, so for the row of thumb here, so you have AR, geometric, and spikes, depending on spikes. For MA model, here is spike, here is geometry. So for ARIMA model, this is a geometric and geometric. Okay. So by looking at this model, we can say that, let's say the most probably the model is a AR model, AR2. Okay. But what if I assume that the model here is a ARIMA model? I assume just a ARIMA model. So we have just now we have AR2. Let's say I want to combine AR2 and MA model. So let's say I want to combine AR2 and MA. Let's say I want to put MA1. I want to do one different things because of we need to do a different thing. So let's say I want to do one different thing. So my model here become ARIMA P equal to 2 D. I do a one different thing. Let's say I want to do a one different thing, and Q is equal to, let's say I assume that MA1, AR2 and MA1, ARIMA 21 or ARIMA 211. So I assume that ARIMA 211. So let's say we assume that the model is ARIMA 211. Let's say we go to this part. Okay, we go back to our Excel just now. So we go back to our Excel. How to run the model here. Now this is the Excel just now. We are download from real statistics. Okay, we download from real statistics how to find the how to draw calculate the ARIMA model. So now, so to find the ARIMA model here, so you get this real statistics time series from the website. Just Control M, do a right Control M. You just type Control M, press Control M, just Control M, press Control M. So just press Control M. There is if you press Control M, if you press Control M, you will get this function. This function will pop up. This is the function. So you press Ctrl N, the function here is, you just select time series. So you just select time series, you just uh, go to ARIMA model and forecast. So you just click here, then you click OK. Then they will ask you the input range. The input range here, it means your data. So I just highlight this data. Okay, I just bring it down here. This is my data, Y data here. So this is my Y data. Then I tap enter. So we just now we say that we want to use ARIMA 211. So AR2, MA1, and the differences is equal to 1. Difference is equal to 1. So do a forecast. So I do not want to put a constant here. I just ignore the constant here. I just click OK. Then this is the result for my model here. This is the model here. So the model here is they will give you the model here. It will give you the model here. So in other words, this is your 5.2. 5.2. Here is your 5.1. And here is your theta 1. So if you put here ARIMA model, so this is your, so you can write here, you can write here, so this is your, so the model is like this, eh? So the model is yi is equal to, we do not have a constant, okay? We ignore the constant. So 50, so we ignore the constant 50, we do not put a constant, plus by 51 yi minus 1 plus by 52 yi minus 2 plus by epsilon I plus this is a AR2, isn't it? This is AR2 and plus by epsilon I plus by the MA1. MA1 is theta 1 epsilon I minus 1. So by taking this value, so we just pick up the value here. This one become, the model here become yi is equal to, so phi 1 is, so we do not have a 0 phi 0 because of we do not take into consideration the phi 0. So we start with phi 1 1 point, sorry, 0 point, here is 0.5456348 y sub I minus 1 plus by your 5.2, 0.559115, then plus by epsilon I plus by theta 1 is negative 1.11181 epsilon I minus 1. These are your model. So in other words, your model, I can write here yi, the model is yi is equal to 0.4563 y sub I minus 1 plus by 0.559 y sub I minus 2 plus minus by 1.1118 epsilon I minus 1 epsilon I minus 1, then epsilon I minus 1 epsilon I minus epsilon I minus 1 epsilon I minus 1 plus by. This is our ARMA model. So ARMA model 2 1. ARMA model 2 1. But we know that we do a differencing just now. So we have to consider the differencing. We have written a one differencing. Okay. So now because we are doing a differencing just now, we have to consider the differencing. So I go to this one. So this part. Okay. So because we have a differencing just now, we have a differencing. Then we okay. So now the initial model, this one, this is the initial model. So because we did a differencing just now, we have to consider. So our original model just now is yi. Okay, the original model is yi y sub I is equal to phi 1 is 0.456 y I minus 1 plus by 5 2 is 0.559 y I minus 2 plus by epsilon I minus by theta 1 is 1.112 epsilon I minus by 1. So because we have a differencing just now, every of each yi here we minus by the previous data. So yi here is actually yi because of d is equal to 1 here, d is equal to 1. So we did a one differencing. So here become yi minus by yi minus 1, the first one, equal to 0.456 yi minus 1 minus by yi minus 2 plus by 0.559 yi minus 2 minus by yi minus 3. Okay, yi minus 3, yi minus 3. So yi minus 3 is I have yi minus 3 here. I minus 3, then plus by epsilon I minus by 1.112 epsilon I minus by 1. So if you solve this one, you solve this one. So if you solve this part, this equation, if you solve this equation, you'll get yi minus by yi minus 1, 0.559 yi minus 2, yi minus by 3, plus by epsilon I plus minus by 1.112 epsilon I. This is the equation here, the same thing here. So if we express in terms of yi here, so yi here is equal to 1.456 yi minus 1 plus by 0.103 yi minus 3 minus by 0.559 yi minus 3 plus by epsilon I minus by 1.112 epsilon I minus by 1. These are how we write the ARIMA 2-1 model. These are ARIMA 2-1 model. So because of we start with ARIMA we get 2-1, and because of we have one differencing, we have to rewrite the formula here in terms of differencing. Every of each y here you minus by the previous y. Okay? So in other words, yi you minus by yi minus 1, yi minus 1 you deduct by yi minus 2, and yi minus 2 you deduct by yi minus 3. That's how we construct the ARIMA 2-1 model. Okay? This is ARIMA 2-1 model. So how to make sure that your model is better than the other model? You know? So in order to find which model is better than the other model, so you can check the procedure here is to check the AIC and BIC, Aikaki criterion index and BIC. So you can check AIC and BIC. Okay, so you can check AIC and BIC. So for this case, your AIC here is equal to 26.76 and BIC is 37.27. Now let's say I want to write a program here. I want to find what if I do not do the different things because of looking at this graph. I feel that we need to do a different thing or we don't have to do a different thing. This graph is like looks like stationary except for this part. So because of we assume that there is a trend here just now, we do a different things. But what if we do not do a different thing? What happens? So let's say I do not want to do a different thing. So let's say I go to the real statistic just now. Okay, I just cut this data. I just copy this data into new worksheet. New worksheet. So I just copy this data into new worksheet. I try to find the graph here. Want to find the new worksheet. I just add the new worksheet here. So I just copy here. So I want to find what if I do not do a different thing. I just control M. So I just go to time series here, go to ARIMA forecasting, say OK. So I say my model is AR2, no different things, and MA1. Let's say I want to put like that. No difference. So we assume that I don't have to do a different. I just pick up ARMA model. Okay. So when I pick up ARMA model, so here I have put the data here. So the range of data here is from this part to this data, the range of data here. So let's pick up the data. So then I just click OK here. So now these are the results. So now my new M here, so theta 2 here is 0.058 and theta 1 is 0.0681 and your phi 1 is 0.68 and phi 2 is 0.05 and theta 1 is negative 0.41. Okay. Now by looking at this, the important thing is that if I want to compare with the previous one, I just compare the value here, AIC here. AIC is 16.68 and BIC is 29.86. So these two value here. So I just copy here. This is for control, say control C here. I just copy here. Just copy into this part. So I just copy here. Let's say I copy here. So this is my AIC and BIC for this is for AR. This is for ARMA 201. Meaning to say there's no differences. So my AIC here is 16.68 and BIC is 29.85612. So ARMA 201 or ARMA 201 ARIMA 201 means ARMA 21. This is also equivalent to ARIMA 21. Okay, ARIMA 201 is ARMA 21. Okay. So for this one, your AIC is 16.68 and BIC is 29.85. If I compare to this one, the AIC and BIC here is lower than this one. These are ARIMA 211. So what to say here? So if your BIC the value here, the BIC and AIC is smaller value, meaning to say this model is better than the previous model. Meaning to say ARIMA 201 is better than ARIMA 211. So even though we first of all we assume that the model is ARIMA 211, but if you calculate model of ARIMA 201, it returns to your AIC and BIC is smaller than the ARIMA 211. We can say that ARIMA 201 is better than ARIMA 211. That's why for this case, okay, for this case, we can say that we choose ARIMA 201 as the AIC and BIC for this ARIMA 201 is smaller than ARIMA 211. Okay, these are the fun. So we select ARIMA 201 because of we based on we our 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 value here we can base on the value of uh, the IC and BIC. So the final model is ARIMA 201. So how to write the equation for ARIMA 201? So this ARIMA 201 you can write like this. The model here become for ARIMA 201 ARIMA 201. In other words, ARMA 21, the model here become y sub I is equal to, so your constant here theta 0 is equal to 2 point, this is theta 0, okay, theta 0, this is theta 1, and this is theta 2. So theta 0 is 2.64135 plus by theta 1 is 0.6814 y sub I minus 1 plus by theta 2 is 0.058 y I sub 2 plus by epsilon I plus by theta 1 is what you call your MA model, your MA theta 1 is minus by negative 0 point, or you just put like this, okay? Sorry, just put just cancel this one off. First we cancel this one. Okay, let's say I rewrite again. I try to get model again. I just show you how to get model again. Okay, okay. I just copy this one. I just copy this one. I try to get a new model. Okay. Go to new tab here. Okay, I go to control M. So I try to get the new model here, ARIMA model. So I do not want to put a constant here, okay? Because of here I put here 2, here 2, and 1. There are no different things. So my data is this one. This is the data. Two zero six. So then just click OK. ARIMA mod 210, no different things. Just click OK here. Okay. Now the model here is your model here is a y sub I. So the model is because I do not want to put a constant here. So y sub i is equal to, there's no phi 0, so we start with phi 1, negative 1.60651, sorry, 1.0626, yi minus 1, y yi minus 1, minus by 52 minus by 0.606 yi minus 2 plus by epsilon I plus minus by 1.05 theta 1. This is a theta I minus 1. So theta I, sorry, epsilon I minus 1. Epsilon I minus 1. This is epsilon I minus epsilon I minus 1. These are our new model. In other words, ARIMA 201, or ARIMA 201 is ARMA 21. Okay. So try to get this software or real statistics software and try to find try to solve how to play with ARIMA model, and so on and so forth. Okay. So we select this model because of the value here is AIC here is smaller than the previous one. Okay. AIC here is smaller than previous one. Okay, now okay, this is how you got the model, and then you can try the you can download. Don't forget to download the ARIMA model. Then you can also draw a graph here. You can plot a graph here from these real statistics here. You can plot a graph here. You can also plot. Let's say I want to plot a graph here. I just control M here. I want to plot. I want the time series. I want to test a polygram. So range of data here. You can also plot a polygram here. Polygram. And then input APs, output AP, ACF, range ACF, okay, of number of lags. So just put okay now. Okay, these are polygram. You can draw a polygram, ACF, and so on and so forth. You can play around with this software to find which model fit the best. Okay? So just now we assume, first of all, we assume 211. Now we change to 201 because of we feel that the trend here is not that strong. Okay? We feel that the trend is not that strong. We say that maybe we don't have to do different things. First of all, we by looking at this graph here, first of all, we think that uh, the thing here we should pick up we should do a differencing, but if you do not do a differencing, the result is much more better than differencing. So we don't have to do a differencing. That's why we choose ARMA 21 instead of ARMA 211. I think that's all for today lesson. What you can do is you can the same thing. You can please can you refer back to your previous data? This is new assignment. You go back to the new assignment here, a new project, okay, a group project, a group project. Group project, group project. Okay, now for the group project, can you refer to your the previous data? For example, I have asked you to find Facebook data. Then you will need to find the Facebook, the Google, for example, Google, Tesla, and so on and so forth. So use the previous data, the previous project, and try to use this real statistics software. Real statistics software. Please download this real statistics software, and then try to find ARIMA model. So try to find ARIMA model, test a few model on ARIMA. Let's say, for example, you want to you test 2, 1, 1. Maybe you can test 2, 2, 1, or you can test 1, 1, 1, or you can test 1, 2, 1, or you can test a few more. You can test uh, 2, 1, I say 1, 1, 2. You can also test 2, 1, 2, for example. And then you can also test ARIMA 2, 1, 2, 2. Okay, 1, 2, 3, 4, 5, 6, 7. And also you can test the ARIMA 1, 0, 2, 1, 0, 1. You can test ARIMA 2, 0, 1, and then 2, 0, 2. Okay, try to find which one is the best model by referring to AIC and BIC. Okay, so download the real statistic software. Based on the previous data, you have Facebook, Google, etc. Just pick up your own data. Let's say, for example, your group doing a Facebook data. Just pick up the data and try to run the ARIMA model by using real software, the real stat software you can download from the website just now, and try to test a few models here. ARIMA 211, 221, 112, 121, 112, 212, then 122, or maybe you can test 102, 101, 201, 202. Then pick up, then compare with the AIC BIC model. Which one is better? Okay, then so each group you have to send to me the assignment you send through the email. Okay, so I think that's all for today's lesson. Until next week, so I give you 2 weeks to do this project. So these are the third group project, so submit to me. I give you 2 weeks to complete what you call this project. Then I will what you call I will provide the my guru. So I will provide the platform for you to submit this project. So these are the third project for a group project. Okay. So that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.